So what was it, 1B?
Yeah.
Yep.
Yeah.
I'm very confused by my own thing that I'm doing right now. I don't know. All right, Jennifer, read 1B. What does it say at the top?
Working at energy efficiency.
Yeah, what is it? What's the situation with 1B?
Oh, you want to read the first question?
Yes, please.
Okay, what does the following series of energy pie charts tell you about the behavior of atoms?
And what do they look like?
So it's 5 of them, and the first one is gravitational, then it's 1/4 like empty, and then 3/4 is gravitational, then half gravitational, 1/4 gravitational, and the last one is empty.
Like that?
Yeah.
All right. So what does gravitational energy tell you?
Are you asking me?
That is following.
Oh, yeah, that it's falling.
Well, gravitational energy itself, you can calculate by doing MGH, true? So what do you notice about the amount of gravitational energy each time?
That it goes down.
Because the amount of gravitational energy is decreasing, what does that tell you about the actual behavior of the object?
It's
Yeah.
following.
It may be speeding up. This doesn't say it's speeding up. So if this were more kinetic energy each time, it would be speeding up. But that's like a good B, right? It may be speeding up. Something else may be happening. Go ahead.
Is it that it's following?
So it's getting closer to the ground, right? It's getting closer to the ground because this is decreasing, which means the height is decreasing. Does that make sense? So we could come up with any number of scenarios for this. One, you could say it's an object that's falling, right? And it falls all the way to the ground because what do you notice about your gravitational energy in the last one? There's none, which means the ball ended up on the ground. Someone also said like, oh no, it's a cart going down a hill. Is that a possibility? Sure, because if you look at it here, and then here, and then here. So in both of these scenarios, what would the rest of our pies be then?
Last one was kinetic energy, and then the last one was thermal.
So EK, EK, EK. And here you could say it's EK, this is right as it's striking the ground, or you could say it already hit the ground, and you call it thermal. Right? So this is kind of an open-ended question where you're trying to figure out what does the pie charts tell you? In this case, the pie charts, because the gravitational energy is getting less, therefore the object is getting closer to the ground. Does that sound good? All right, and then 2 was suggest a scenario that goes with whatever that makes this happen. Then fill in the blank. Okay. All right, what does 3 say?
When driving down the highway, the engine has to supply a constant source of energy to the car. If chemical energy of the gas is being consumed, why isn't the car speeding up? Why isn't the kinetic
Okay.
energy increasing?
If you look at pie charts for all 3 of these, okay, it says the speed is the same for all 3, true? Okay, so I'm going to put some kinetic energy here. What happens? How do you make your car go? What do you need to put into the car to make it go?
Gas.
You need to put gas in, right? And when you press on the gas pedal, the engine goes, right? Where does it get that energy from? It gets it from the gas, people, right? It gets it from the gas. So in this one, I can do something like all the rest of this is E. I'm going to put a CH there. What do you think the CH stands for?
Chemical.
It's chemical energy, that's right. So when I go from here to here, I've used up some of my gas, true?
Yeah.
So what do I know about my chemical energy? it's a little bit less, and then later on, what else do you notice? It's a little less. So I'm using up the chemical energy, yeah? But the kinetic energy is the same. So what's filling in these gaps here? Is it some thermal energy? Sure. A car is a very large object. And when you drive it, it has to move through the air. All that air that's rubbing on your car is generating all this thermal energy, which if you don't keep putting chemical energy in, you're just going to slow down. Right? If you take your foot off the gas as you're approaching a stop sign, will you slow to a stop? Yes, you will. And that's all the thermal energy that's generated between the car and the air it has to move through, and all the internal working parts. Right? All the internal working parts generating a bunch of thermal energy. So in this situation, you have your foot on the gas, the chemical energy is decreasing, the kinetic energy stays the same, but look at the thermal energy. It's increasing over time. Yeah?
What are the chemicals that make gas?
It's some sort of, so gasoline itself is, so it's octane, okay? So octane, now it's not fully octane. So oct means it's got 8 carbons in it, but it's got some pentane, right, which means 7, and probably some non-ane, means 9. And so gasoline itself is a mixture of these anes, and they're very combustible, which means if you mix them with oxygen and provide a little bit of a spark, it's going to blow. Okay, this is what happens in an engine. So we have this cylinder here. Okay, we have a cylinder here, and then attached to the cylinder, okay, and it fits really nicely in here. There's what's called a piston. Okay. And so this fits nicely in here, and you can move it up and down in here. It doesn't move, it's really tight, so it doesn't move easily, so you need oil on the sides of this so that this thing slides up and down easily. Because what happens is, you pump the gas in here, there's a little valve here, pump the gas in here, you pump the oxygen in here, and at the bottom of this, is a spark plug. You ever heard of a spark plug? So what happens is, this thing is going up and down with the engine. And then it goes up, and as it goes up, the gas gets injected in there. It's called a fuel injector. Have you ever heard of a fuel injector? It literally injects the fuel in there. At the same time, oxygen gets put in there. Then this comes down, and as this comes down, the spark plug fires. And a little explosion happens inside this little cylinder here, and it pushes the piston up, because it's an explosion. Does that make sense? And then it comes back down, and it happens again, and it comes back down, and it happens again. This up and down motion is transferred to this is what's happening in the engine. Okay? And it's that gets translated to the motion of the tires. Okay? There's a couple steps in between there, obviously.
Might as well be an auto mechanic usually.
Well, I mean, this is a very simplified version of what happens in a combustion engine. But the gas gets mixed with the oxygen, you get a spark from the spark plug, a little mini explosion happens, and that's what powers it. Is that cool? Yes?
Okay, so on Monday, will we have to like redo the whole thing, or like can we just redo it?
Anything you didn't get a 3 on, Jacob. Anything you didn't get a 3 on.
Okay, and for like, when you say how, do you just want us to elaborate on?
Yes,
Okay,
please. All right, what's the next one? Is it about bungee jumping?
yeah.
Love bungee jumping. So when you bungee jump off a bridge, okay? All right, so you're gonna jump. All right, you go down. down, and then you come back up. But you never quite go as high as you did before. Why not? Yeah?
Oh, I was just gonna ask that.
Can we finish first?
Yeah.
So you start up here, all your energy is gravitational, right? Then when you come back up, you have less gravitational energy. True? Where'd it go? Mhm. So all that stuff happens in the middle, right? You're moving, there's some kinetic, you stretch out, there's elastic. But when you come back up to your highest point, you're never as high as you were before. Why not? Because some of your energy was turned into thermal. It's because you rubbed on the air during the fall, because the bungee cord stretched out, right? If you stretch a rubber band out and let it come back, it'll heat up a little bit. And so you're going to compare the original jump to how high you get again, and you never have as much gravitational energy because some of it was turned into thermal, right? It's the same thing with the bowling ball swing, right? You let it go, it goes, it never comes back as high because some of the energy was turned into thermal, so it never has the same amount of gravitational energy it did when it started. Yeah.
How did it turn into thermal again?
Because you were rubbing on the air. As the bungee jumper rubs on the air, thermal energy is generated. What is that?
They dropped.
Again?
Yeah.
You're redoing it?
For like the people that
Oh, yeah.
It's like the easiest thing ever. I'm actually fully convinced that if you just dropped an egg, it would survive.
Why?
Is that it?
Well, yeah, the stretching of the cord, the bungee cord heats up, and that's thermal energy. Okay. Oh my gosh. What's the next one say?
It was the roller coaster one.
Okay. What does this roller coaster look like?
So it's a straight line, and then it's a vertical line. I mean diagonal line, and then yeah.
Yeah? All right, so rank the energies for me, yeah?
Well, I was just gonna say, like, compared to the drawing, when you just drop, you wouldn't go down since it's such like a steep, like, diagonal.
Oh, this?
Yeah.
Well, so the drawing program that I use, it's not easy to make curves. So we're visualizing, It's hard to make curves. All right, so let's rank the energies.
Sorry.
You just keep on dancing. You just go for it. So rank the energies. Where does it have the most energy?
Well, same.
They're all the same. That's right. The energy at A is equal to the energy at B, which is equal to the energy at C, which is equal to the energy at D. Right? Because the total amount of energy stays constant, yeah? Okay, so let's look at the first one. Is it up above the zero line? Yes, right? What does that tell you? There's some gravitational energy, yeah? And what else does it, is it pushed against the spring? It totally is, right? Which means what? Elastic energy, yeah? What about a B?
So, another.
It's all kinetic because it's at the zero line, there's no gravitational, it's not pushing or pulling on any springs, right? What about at C? It's up a little bit now. And what I like about this is it started rolling up the hill, true? So it's probably going to be a little bit slower at C than it was at B, correct? Which makes sense to us because you have less kinetic energy at C than you do at B. And what about at D?
So, gravity.
How's that? Yes, no, or maybe? So, yeah. Okay, and then what about this? Starts off with elastic and gravitational energy, right? Rolls all the way to D. At D, it's all gravitational energy, but there's some friction, so along the way it lost some of the energy to thermal. Right? How do you feel about that? Is that cool? All right, what was that? Was that 1B? All right.